grade 10s, most of our focus in data handling is how to represent data accurately. However, it is possible to represent data accurately but to give a false impression of the information. Justice has this problem in his restaurant. He asked his waiters to get the customers to rate their service, but he thinks some of the waiters may have used dishonest methods. He has asked Zinzi, who has helped him with other data collection, to help him sort out this problem. Let's see what they come up with.
Welcome, Justice.
Hello, Zinzi, and hello, everyone.
Well, so far in this series of lessons, we've used data handling techniques to help Justice to improve his restaurant.
Zinzi, the help I got here is so valuable that I have decided to come back for some more.
Glad to hear that.
Well, last month we did a survey on waiters, the one you helped us with. So I'm afraid one of the waiters might have recorded incorrect data.
Well, what do you think he did?
Well, we did a survey to find out how customers feel about specific waiters. We were trying to find out which of the waiters needed extra training.
I remember.
Well, one of the waiters gave the survey to the customers he knew he had a good relationship with. So that made sure that he achieved high scores.
Oh dear, Justice. Well, how would you like me to help you?
Well, first of all, I'd like to know if what the waiter did, will it affect the results? And if so, what is it that we could have done to prevent it? This also got us thinking about the data handling altogether. What other problems could there be?
Well, there are many ways to affect or manipulate data, but there are also ways of preventing some of these manipulations. Let me show you all the problems that can arise, as well as the manipulations that can be made. I'll also show you how you could try and prevent these manipulations from happening. Well, once you have this knowledge, you'll be able to avoid being fooled by any manipulations in the future. Well, what your waiter did is quite a common problem in census and surveys. It's called bias. Biased data is when data does not accurately represent the population, but is manipulated to represent a specific view. In this case, to show that the waiter provides good service.
Can you explain a little bit more?
Well, Justice, let me give you a scenario. Say the governing party wants to do a census on how happy the population is with them. If they only ask people from a certain area that's received good service, the census will show that the population is very happy, even though the rest of the population may be very unhappy.
I understand. So the census is not actually representing the whole community, but only a few.
Exactly, and this is called biased data.
I get it.
Remember when I explained to you the concept of sampling, where we use a small portion of the population to represent the whole population? The way in which you do the sampling can affect the data and either create bias or prevent it.
So you are saying there are different ways to do the sampling?
That's right. I'll quickly explain 5 methods of sampling to you. The first is called random sampling. Random sampling works on the idea that every person in the population is equal and has an equal chance of taking part in the survey or census. We then use a random selection technique to select people to participate in the draw.
What is a random sampling technique?
It's a technique that makes the sampling random. For example, drawing from a hat or using a computerized random selection tool to determine whether a person should be used in the sample.
Oh, so if we used this method to find out about the waiters, they would have no control over which customers would be surveyed.
Exactly. The next method of sampling is called systematic sampling. Now, this method of sampling involves following a specific structure. There's a starting point and an end point, as well as a specific structure as to who is being included in the sample. An example of this is if you select every 5th person, or every 10th person, or 20th.
I guess that makes sense, and that would also make sure that the waiters wouldn't be able to affect the results.
It would also ensure that the sample covers the whole population quite evenly. Now, the third method of sampling is called stratified sampling. This method of sampling looks at subgroups within the population. Random samples are then taken from the subgroups, but in proportion to the size of the subgroups in relation to the whole population.
Explain that more.
Well, let me give you an example. Say 20% of your customers are teenagers. Break your sample population into teenagers and adults. Randomly sample each group. Just make sure that 20% of your sample comes from the teens and the other 80% from the adults.
Okay, I see.
And the last method of sampling is called cluster sampling. Now, this method of sampling selects a specific group according to some characteristic unrelated to the survey data to be used as the sample. Well, as an example, you might choose to select men with bald heads, or to select women wearing flat shoes as the only people to sample in your waiter survey.
Well, that is almost like another way of taking a random sample.
Precisely. It's often cheaper than trying to conduct a random sample that requires a computer to generate the random selection.
Okay, that sounds useful.
And that covers sampling for you.
Zinzi has a good point. The sampling method you choose will help to avoid bias. Remember, bias is when data is manipulated to make it look more favorable. Let's see what else Zinzi has to add.
The most common way that data is manipulated in data handling is by means of changing the appearance of a graph to look more favorable towards a specific event. This is often achieved through changing the scale on the graphs or through omitting points on the axis. Well, as an example, let me show you this graph of two of the waiters' scores. Look at this and tell me what you think looks like the waiter with the better service skills.
Well, looking at these results, it looks like waiter number 1 has achieved better results.
Notice the scale on each of these two graphs.
Now that I look at the scales used, I can see that it's not so obvious to see who the better waiter is, because the scales are different.
Yes. If you look at the first graph, the x-axis goes from 0 to 6, while the y-axis goes from 0 to 25. Now on the second graph, the x-axis reads from 0 to 10, and the y-axis from 0 to 70. Let's now put these two graphs on the same scale and see which waiter produced better results. It's now much clearer waiter 2 achieved better all-round results.
Oh, that's amazing. I can see how someone could manipulate data to present graphs showing something of their choosing. This can really be dangerous if you don't know what to look out for.
Well, that's true, and you'll be amazed how often it happens in everyday life. Justice, let me show you another way graphs can be manipulated. This graph shows the average scores of the two waiters. The graph's y-axis has been contracted in a way that makes one waiter's mean score look twice as large as the other waiter's. If you look at this graph now, with the y-axis correctly drawn, you can see that the mean scores of the two waiters are very similar.
Wow, I never realized what a difference scales and axes could make to the way we read graphs.
As long as you're aware that graphs and data can be manipulated, you shouldn't fall victim to any tricks that a person or organization might try to pull on you. Look at graphs with a clear understanding of how they should be drawn.
Oh, that's great. Thanks so much for all the help.
Well, it was only a pleasure, Justice, and thanks for coming.
Isn't it amazing how changing the scale on the y-axis can affect the way the data is interpreted? It makes you rethink the way you look at data handling, doesn't it? Now Zinzi will recap what she's covered.
Let's recap what we learned today. We learned about the 4 different methods of sampling: random sampling, systematic sampling, stratified sampling, and cluster sampling. These methods are used to avoid biased data. Remember that graphs can be manipulated to paint a specific picture instead of the real one. So always look at scale and axes.
Thank you, grade 10s. That was a good lesson. You may wish to try some of the tasks in the data handling task video. You will also be able to learn more about data handling on our website, www.mindset.co.za/learn. Goodbye.